Alright, so particle motion is going to be the same thing.
It doesn't show up on TV.
Okay.
Like it had a pretty leopard. Oh, gee. I don't know.
Now?
Yeah.
Okay. It's the same thing that we've been doing, but instead of it being like free fall, it's just going, moving along the line and talking about its position and all of that. So again, if we have a position function x or s, what is the velocity, or how do we find velocity? The derivative of the position, and how do we find acceleration? Right, okay. So, and also, again, this is relating a lot to physics. Some of it should sound familiar from physics. A particle moves along a line so that its position at any time when t is greater than or equal to 0 is given by the function s of t equals t squared minus 3t plus 2. Where s is measured in meters and t is measured in seconds. Okay, part A says find the displacement during the first 5 seconds. So, any ideas about how we would find the displacement, or what does that mean from what you know about physics?
Like, if I don't know how I'm going to put this into words.
We need its final position.
Its final position as opposed to its
Distance?
what?
Beginning.
Right, so we're actually going to have to find the beginning position and the final position, and then what will we do with those? Subtract them. Right. So to find the displacement during the first 5 seconds, we're just talking about position, so we'll find the position at time 0, which is going to be what? 2, and the position at time 5. Which is
42.
40. So what is the displacement?
Why?
Oh, I wrote that wrong, down wrong, didn't
I
I?
was like, how did you get 42?
Sorry. I wrote it down wrong. So it's 25 minus 15 plus 2, so that would be what? 12. My bad. Thank you, Skylar.
I got really confused. I was like, I swear it's minus.
12 minus 2, so the displacement is 10. I thought that was awfully long distance for 5 seconds. I must be booking it.
Could it be 10 meters?
Yes, they did tell us that S is measured in meters, right? So 10 meters, good. Alright, and then they ask us to find the average velocity during the first 5 seconds. So how do we find average velocity?
Absolute value.
What?
The absolute value of the. No.
You're probably thinking of speed. We say speed is absolute value usually. Do you remember that from physics, the formula for average velocity?
Displacement
Final.
over time or something?
Right, displacement over time. So since we know,
10 divided by 5.
yes, so 10 divided by 5, so the average velocity is what? 2 meters per second. So we don't need calculus to do either of those things. But now they say find the instantaneous velocity when t equals 4. So instantaneous velocity means what? Right, I have to find the derivative. It means what is the velocity at that exact point in time. So if I have a speedometer, I look at my speedometer and see how fast I'm going at that point in time. So if we have the curve, then we'll have to find the slope of the curve at that point. So we have to find the velocity function, which is what? The derivative, right. So what's the derivative? S prime of t, or in other words, v of t.
So we have to do the derivative first and then plug in for t?
So what's the derivative of the position function?
2t minus 3.
2t minus 3. Good. So then, yes, they're asking for it at time 4 seconds. So that will be, what? 5 meters per second. Good. Okay, and then part D says at what values of t does the particle change direction? So how do you think we're going to figure that out? Do you guys both have your graphing calculators? I'll give you one. Well, I'll give you one.
It's charged today, but
Oh.
I have it. I just brought this one because it's easier to use.
Let's take a look at this position function and see if that might help us at all. So, do you remember how to start graphing? What we would do?
Press
You need assistance.
there we go. Okay. Press the graph button.
Before we press the graph button, we have to tell it what to graph. Which button? Y equals, yes. So first press the Y equals button.
I'll have to turn it on first. There we go.
You probably have something already typed in, so you want to hit clear. And then it's going to be t squared, or you're just going to use the x, which is underneath the mode button. So x squared minus 3x plus 2.
I don't see where the x is. Oh.
It's under, right there. Under the mode button. It
Oh.
says like x, t, theta.
How do I make it squared? Oh,
Yep,
okay.
like that.
No, I was
Like
used to
getting
my
used to a
calculator.
different calculator.
I'm just getting confused. Now hit graph.
Now hit graph. But your window is probably still what your window was the last time, right? So go to zoom. Your window's actually probably fine, Skylar.
Okay.
Zoom fit, which was 0. Which actually is still not that great on mine. Mine's usually quick. Yeah, because we changed. So go to window. And change your window to just -10, 10, and then -10 and 10 for the Y.
What do I do for X, SL, CL?
Typically just one, like that's
One.
the, yeah.
And then I press graph.
Yes. And hopefully that makes it better. Or easier to see. Okay. So that is the position of the particle, right? But we're actually only concerned about time greater than what?
0.
Time greater than 0, yeah. So we're actually only concerned about the positive values for that function. So I guess we could have just left it at 0 for the x. But anyway, you get the idea. You might need to change your window as things go. But what is happening? When is it going to be changing directions?
When it's at the bottom of the parabola.
Right, when it's at the bottom of the parabola. And what do we know about the bottom of the parabola?
It's a negative number.
What do we know about the slope of it?
0.
The slope, so this when the slope of the what? Tangent is 0. That's when it will be at the bottom of the parabola, right? The last time we had an upside down parabola, right? And we were finding the maximum height. Do you remember when we were doing that? When we were looking at the graph? And we said that if we find the derivative at the maximum height, that would be a horizontal line. The slope at the maximum height would be a horizontal line. So where the derivative equals 0 would be the maximum. Here, it's actually a minimum, but it's going to be the same thing. So when it's at the bottom of the curve, then that's when it's going to change directions, right? Okay. So, how will we figure out when that is? We set the what equal to 0?
Velocity.
Set the velocity equal to 0. So the velocity function we found in part C. So if we make the velocity 0, that will tell us when our object is changing directions. So 0 equals 2t minus 3. So that would be at 1.5 seconds, or 3/2 seconds. Do you guys understand why that's true? Yes? Skylar? So our graph kind of goes like this.
I understand how to do the math. I just don't understand why we use the which equation to use in each situation.
Which is what I want you to understand. Right?
That's what I'm getting confused
So
about.
if we have, this is the position, say this is a rough sketch of the position function. We know that when the position is at the minimum point of this curve, that's when it's going to change direction. Does that make sense to you? Right? So anytime you have a curve like that, and it's at the very lowest point, or in our other example is at the very highest point, when we draw the tangent line to that point, it's going to be horizontal. And the tangent line tells us the derivative, which tells us the slope, which is the velocity of position. Right? So I have to find when the velocity is 0 in order to do that. Did graphing it on your calculator help you to figure out what you need to do for that problem? If it doesn't, then no. But then that's okay. I was just wondering if it helped you to think about it at all. No, not really.
Nah.
You would be able, you would know that without looking at the graph, that you would need to find when the velocity is 0.
I think so.
Okay. Good. Alright, and then E says, where is the particle when S is a minimum? So, where is S a minimum?
So that means when S is 0?
A minimum means not necessarily 0, but the lowest point, right. And so we just figured out the time. This was the time at the lowest point,
Mm-hmm.
right? So we need to figure out what S is.
So we just plug that back in.
Plug that into which one?
The original.
Right. So we're finding S at 3/2 or 1.5. S was t squared minus 3t plus 2. What'd you guys get? Yes? Okay, either one of those is fine. So it's actually below the line at that point.
I didn't get that.
You didn't?
Mm-mm.
What did you get?
I got 4.25.
How did you get 4.5 for that? Did you add those? You should multiply. You should multiply negative 3 times 1.5. Or 3 times 1.5.
I multiplied
It looks like you added them. I don't know, what is it?
My friend multiplied it.
That's weird.
Gives me 2 different answers. What? So it gives me 2 different answers.
That's really weird.
Yeah.
Oh, okay. That's still right. I don't know what you... Like if you type all of that in a row, it should give you that. Yeah.
I don't know why. Okay.
But if you do, even if you think maybe the graph didn't help you that much, if you want to check your answer for minimums, I'll show you how to do that on your graph. If you go, you already have a graph, so if you go to second calc, which is above where it says trace,
Go to minimum.
go to minimum, yep. And then it will ask you to, hit enter where it says minimum. It will say left bound question mark, and so there's a little flashing cursor. If it's on the left hand side of the curve, which I think it is on both of yours, you just hit enter. And then it will say right bound, and then you need to use the arrows to move it over to the right hand side of the curve. And hit enter. And then enter again where it says guess. And then it will tell you that the minimum is about 1.5, and the x value is 1.5, which we said 1.5 seconds, and the y value is negative 0.25. So you can use your calculator to check that if you would like.
Oh, interesting.
Cool.
Okay.
Cool.
Just so you guys know what your calculators can help you with.
I can actually figure out my calculator.
Alright, so let's go ahead and do number 2 together, and then you guys can do the others. So, the same thing, a particle is moving along the line so that its position is given by the function s of t. Can you guys see my thing? Yes? Okay. S of t equals negative t cubed plus 7t squared minus 14t plus 8, where s is measured in meters and t is measured in seconds. So the first question they ask now is the instantaneous velocity at time t. So how do we find that?
True.
Right, very good. So velocity is the derivative of position, so we find the derivative of this, which is going to be what?
Negative 3t squared plus 14t minus 14.
Good? And it just says at time t, so we're just leaving that as a function of t. Part B asks for the acceleration at any time t. So how do we find the acceleration? Second derivative of position, or in other words, the first derivative of velocity. So if we find the derivative of velocity, that will give us acceleration, which is
Negative 6t plus 14.
good. Negative 6t plus 14. Okay. C says, when is the particle at rest? So if we know a function for position, velocity, and acceleration, which of those functions would we want to use to figure out when it is at rest? Velocity, and we would want to know when the velocity is what? 0. Right. So we will set the velocity function equal to 0. So you're going to have to use the quadratic formula for that. You want to sing the song for us, Skylar? X equals negative 14 plus or minus the square root of 14 squared minus 4 times negative 3 times negative 14 divided by 2 times negative 3. So we're gonna have decimals here. I guess it's actually t, not x. So t is about 1.451. And about 3.215. Is that what you guys got?
I got the 3.21, but I can't figure out how to get the other one.
You did negative 14 minus the square root of 28?
Well, I factored out 2. So I have negative 7 plus square root of 7, or minus 7.
Okay. So you did negative 7 minus the square root of 7?
Divided by negative 3.
Divided by, oh right. Then you need to do negative 7 plus the square root of 7.
Oh, okay.
Did you get that, Sky?
Yeah. For the next question, would it be the same thing?
That is where it is changing directions. Yes. Describe the motion of the particle at what values of t does the particle change directions? Well, where does the particle start?
At 0. Like for time or for position?
Well, it starts at time 0, right? And position is going to be what? To describe this, we want to know where it starts, then in what direction it's moving, and then when it changes direction, or when it stops, changes direction. And when it stops finally, I guess. So why don't you leave part D, we'll talk about part D on Monday, and the rest of the questions are the same. So do parts A through C on numbers 3 and 4 and leave. We'll talk about part D on Monday. Okay? The graph is going to be really helpful for those, I think.